Alright, for math class this week, we are to find the area of an ellipse such that when you graph it, this vertices, the co-vertices, we say, is 0b, and the vertices is a 0. Okay? And you can write this equation as x squared over a squared plus y squared over b squared equaling 1. And you can rewrite that to be y squared over b squared equals 1 minus x squared. Then from there you can say y squared equals b squared, 1 minus x squared. Then you just take the square root and y equaling b times square root of 1 minus x squared. And the reason why it can be positive in this case is because we're going to take the integral of this 1/4 sliver so we can get the area of the full. And this is just positive across the x-axis, so we don't have to worry about the negative sign. Okay? So from there we can say that 1/4 of the area equals the integral of b over a from a to 0, 0 to a, because we're taking it from here to here, of this positive portion, okay, of a squared minus x squared with respect to x. Okay? Alright, we're going to do a little bit of trig substitution here and say that the triangle is, make a triangle x of a for an angle theta. So we get sine theta equals x of a. Okay? Oh, by the way, and the reason why we said squared of minus x squared of a is because we could take out an a squared and we could take out this a squared and this would become a square root of a squared minus x squared. Okay, so from there we're going to say that, so that means x equals a sine x, dx equals a cosine of x. Okay, from there we can say that we also want x squared because, you know, we need to plug in x squared back into the equation. So x squared equals a squared sine squared of x. So as of right now, we can sub in all our values and say that 1/4 of a equals positive b over a, the integral from, excuse me, we can't even do that. Okay, so whenever you sub in anything and you sub in with respect to x, sub in with respect to x to be respect to anything other than x, such as theta, from which we subbed in, d theta, we have to account for the change, and we have to take the lower bound where at x to be theta. Same with the upper bound. So that means what I'm saying is sine 1 of x. Inverse sine of x over a equals theta. So that means from 0 in a, so that means inverse sine of 0 over a is simply 0, and the sine inverse of a over a, which is 1, equals pi over 2. Okay? Alright, so that's from 0 to pi over 2 of, let's see here, a squared, excuse me, square root of a squared minus a squared of sine squared theta cosine theta. Remember that being your d theta, right? Alright, so from there we can rewrite this a little bit and take out the a squared. So AB, 1/4 of the area equals AB times the integral of 0 to pi over 2 of, and 1 minus cosine theta, or just sine theta, using our trig identity, cosine theta plus sine squared theta equals 1. Excuse me, cosine squared theta plus sine squared theta equals 1. Okay, with respect to cosine theta, over cosine d theta. Okay, excuse me, this was a sine theta, sine squared theta. So that was just cosine squared theta. We take the root of that. So we end up with AB times the integral from 0 to the power of 2 of cosine squared theta d theta equaling 1/4 the area of an ellipse. Okay, from there we can go further to say that the full area of an ellipse is equal to 4 times AB, the integral of 0 to the power of 2 of cosine squared theta d theta. And with that we can use a trig identity. 1/2 cosine squared theta equals 1/2 1 minus cosine 2 theta d theta times 4AB, which just, excuse me, you still have to integrate this. You can't just, not integrate it, because otherwise you want to get your area. So area of an ellipse equals 2AB times the integral of 0 to the power of 2 of 1 minus cosine 2 theta d theta. We can evaluate this to be, take the indefinite integral, 2AB times theta, because we want, the integral of 1 is theta in this case, because we're taking the respect of theta. And then here, this one would just be 1/2 sine theta d theta. Okay, and you evaluate that to 0 to the power of 2. Okay. Alright, from here we can say that we can evaluate this, and the lower bound theta equals, the lower bound theta equals 0 minus 1/2 sine 2 times 0, which is just 0. In the upper bound, we can say that theta equals power over 2 minus 1/2 sine of pi, because power over 2 times 2 equals just pi, which again still equals 0. So the only thing we're left with to work with is power over 2. So the area of an ellipse equals 2 times AB times pi over 2. These two cancel, and the area of ellipse equals pi times A times B. And without a doubt, that's your answer. Thank you all for watching.